Welcome. Thanks for coming to my lab experiment. Today I will be discussing the lab experiment regarding nanomedicine, particularly carbon nanoparticles that have been treated with gold. In this experiment for high school students, I picked an assignment that was able to explain to kids how nanotechnology works. It's such a minute, I'll have to skip that. It's such a difficult concept for kids to understand because of the minute nature of the particles. So I found an experiment that used artificial tissue, and the artificial tissue happens to be, if you want to come in close and look at this, happens to be Jello Kool-Aid gel snack cups or whatever. And how it's been treated is, if I can hold it up to the light, can you see that? Mm-hmm. This is gelatin. The red gelatin is the Kerrigan gel that was part of the ingredients of the Kool-Aid. And then the yellow center is gelatin, non-flavored gelatin that's been treated with yellow food coloring. Now the center here is the cancer treatment nanoshells, and the outer part is considered to be the healthy. So the nanoshells have already been pre-injected, and the lab experiment is set up so that the laser, which happens to be represented by this heating lamp, is about 20 centimeters from the surface of the nanoshell. We apply the temperature, or the laser in this case, and we take the temperature using a thermometer. And the thermometer, we just monitor every 30 seconds. And if I can have you go over to my lab book. Students will set up their lab book somewhat like this. They will put the headings on top, the list of materials, the procedures that they're going to follow, and they're going to state the hypothesis of what they believe the experiment will show them. In this particular hypothesis, I stated that tissue will be destroyed along with cancer cells. Students may have something different, but anyway, they can come up with their own hypothesis. So, over here on this side, they'll set up what they think the purpose is of this experiment. They will design a table with time, starting at 0, and take 30-minute increments of temperature. So their observations, they will mark in as well.
30-second increments, 10 minutes.
Oh, 30-second increments, sorry. They will take measurements every 30 seconds and record the changes, if any, in the tissue. Now if we can go back over to our tissue. Our tissue, as you can see, is well intact. The center is still very thick and hasn't melted yet. When I did the experiment, it took about 7 minutes before it completely become liquid again. And the exterior, or the healthy tissue, was still intact. And one of the questions that the students will have to answer is they'll have to explain why they think the tissue, or the gel in this case, didn't melt. And it's suggested that the students come over to the ingredient panel and check out the ingredients and make a hypothesis or make some sort of observation in the ingredients panel as to what prevented it from melting. The gelatin, the unflavored gelatin, the ingredient panel will also be provided for them to make some sort of guess or observation as to what kept it at its consistency. Okay, the purpose of this lab experiment is for students to investigate what they already know about cancer treatment and to explore the new technology of nanotechnology as a cancer treatment. They will be provided with background information about current cancer treatment, as well as they will be provided with the new technology, information on the new technology regarding nanoparticles. Students will be provided students will be provided with this background information. They will also be asked to work on a bell work question, and the bell work question will ask them prior to the experiment what they know about current cancer treatments and describe in detail what they know. And this helps to identify any preconceptions that they might have, and also gets them ready to think about how this technology will work. So as they explore the experiment and take measurements on time and temperature, they will understand that the nanotechnology that's been embedded into this tissue is the thing that works on the cancer tissue. It doesn't work on any other healthy tissue. Because of its treatment and its design, it's been embedded with antibodies that seek out cancer tissue only. So they're also given a scenario of a woman named Susan. Prior to surgery, prior to nanotechnology, she is treated under conventional means of chemotherapy. An X-ray is used to detect it. There's some risks with the X-ray. There's surgery that removes the cancer, and then there's time in which the tissue needs to be treated, and then there's radiation that follows up any leftover cancer that may be left behind.